Yay! Congratulations! You survived the SOLs. Actually, I'm really proud of you guys. You did a good job. But we do have to get back to business, so I am giving you a light day today, but I can't actually give you the day off because there's some things we didn't have time for before the SOL that you need in your final. One of those is net ionic equations. So back a couple of units ago, we did solutions. And when we did solutions, I gave you a page in your packet that I told you about. It's called the solubility rules. So those solubility rules are on the handout that you're going to work on next. So you don't have to worry too much about having them memorized yet. But if you are going to take AP Chemistry next year, you do need to memorize those solubility rules. One of the reasons you need to use them is because net ionic equations are usually the simplest way to balance an equation. Plus, they tell us what's really happening. What am I going to see? So, in order to figure out what net ionic equations are, we need to start from a standard equation just until you kind of get used to things. So, I'm going to just make up a random reaction and we'll see how it goes. Okay, so I'm going to start with calcium hydroxide plus barium chloride makes calcium chloride plus barium hydroxide. The first thing I have to do is make what's called an ionic equation. In an ionic equation, we break things up into ions. If they're a solid or they're insoluble, according to your solubility rules, then you're not going to break it apart into ions because it stays together as a solid. If it dissolves in water, then you're going to break it up into its ions. If it's a gas or a covalent compound, it is not going to break up into ions. This is just like when we were doing the Van Hoff factor. If it doesn't break up into pieces, you can't break it up into pieces for this either. So we're going to start with calcium hydroxide. Now, as it turns out, hydroxides are not really that soluble. Lithium, sodium, potassium, ammonium, yeah, they'll dissolve no matter what they're with. Calcium hydroxide is considered moderately soluble, but really it makes more of a suspension than it does dissolve. So we're going to leave calcium hydroxide together. Barium chloride, on the other hand, all chlorides dissolve. So barium chloride is going to break up. It's going to make a barium ion. Barium has a 2+ charge, and it's going to make 2 chloride ions. Okay, just like when we're doing the Van Hoff factor. The barium, there's only one of those. There's 2 chlorines, so it makes 2 chloride ions. And that is going to react to make calcium chloride. Again, chlorides pretty much all dissolve, except for silver. Silver's a little funny. Maybe lead also doesn't dissolve so well. But other than that, chlorides dissolve really well. So calcium chloride is going to break up into its ions. One calcium with a 2+ charge, so I have just one of those, plus 2 chlorides. Plus, we're going to have barium hydroxide. Okay? Barium hydroxide, again, is a hydroxide, and this one really doesn't dissolve at all. Because it doesn't dissolve, we're going to leave it together. So that's called your ionic equation, where you take the things that dissolve in water, you break them up into pieces. The things that don't dissolve in water, you leave whole. Okay? The next part's really easy. Net ionic equation is what happens overall. So if something is on both sides of the equation, you cancel it out. So calcium hydroxide, that's not anywhere on the reactant, on the product side. So we're going to leave that alone. Okay? Barium hydroxide, that doesn't appear with the reactants. So we're going to leave that alone. Barium 2 plus is only on the reactant side, so that's going to stay. Calcium 2 plus is only on the product side, so that stays alone. But you'll notice these chloride ions are on both sides. So we cancel those out. They just go away from the equation. So our net ionic equation is what's left over. So we have calcium hydroxide plus barium ions, wherever they're coming from, makes calcium ions plus barium hydroxide. And that's it. That's your net ionic equation. So what about those chlorides? Well, we have a special name for them. The chloride ions are just sitting around in the water. Nothing's really happening with them. They're not reacting with anything. But they can see what's going on all around them. So we call them spectator ions. Spectator ions are the ones that are left around. They're not really part of the reaction. They're sitting there in the water, but they don't actually participate. In fact, you could replace that spectator ion with anything else, and the reaction would still happen as long as you have calcium hydroxide and barium ions. You will end up with calcium ions and barium hydroxide. Let's try another example just to make sure we have it straight. So we're going to look at one of my favorite reactions, sodium chloride plus, let's go with a fun one. Let's go with potassium sulfate. That'll work. Okay? So we know it's a double replacement reaction. It's going to make sodium sulfate plus calcium chloride. It's 2 calcium chlorides and 2 sodium chlorides, because you guys know how I feel about unbalanced equations. Okay? We're going to make our ionic compound. Well, one of our rules is that everything that's an alkali metal is soluble in water. Okay, that means sodium, potassium, ammonium, always soluble no matter what. So I'm going to make 2 sodium ions plus 2 chloride ions, because sodium chloride, sodium is an alkali metal, it's going to dissolve in water. Same thing with potassium. It's also an alkali metal, so you automatically know it's going to dissolve. So we're going to make 2 potassium ions plus a sulfate ion. On the other side, well, look at that. Sodium sulfate, alkali metal, is going to dissolve. I'm going to make 2 sodium ions plus a sulfate ion. And potassium chloride also dissolves in water. 2 potassium ions plus 2 chloride ions. That's my ionic equation. Now I get to cancel out the things that are on both sides. See, 2 sodium ions, 2 sodium ions, they cancel. 2 chloride ions, 2 chloride ions, they cancel. Potassium ions cancel. Sulfate ions cancel. I've got nothing left over. So my net ionic equation is no reaction. It is possible do not have a reaction. You mix two clear liquids together and they stay clear liquids. Nothing actually happens. So we call that no reaction. So even though we can write a double replacement reaction, that doesn't mean anything actually happens in the container. It's just a bunch of ions floating around. So let's list the spectator ions. Well, that's all of them. So it's sodium, chloride, potassium, and sulfate are all spectator ions, and there's no reaction. So you guys are going to try a couple of practice problems. Feel free to work together, talk to each other, work it out. When you're finished, you will have some time left over most likely. With that time, you can make up any missing work you have, or you can work on something for another class. Just don't be disruptive and don't make a mess in my classroom. Oh yeah, and if you want to make ice cream in class on Friday, then make sure you sign up to bring milk or sugar or Ziploc bags. See you guys on Friday.